water inside it. Me, everything you can see behind me, this ball of dirt, and you are made of molecules. And molecules are made of these very tiny things called atoms. And atoms are made of even tinier things called subatomic particles. Now we believe subatomic particles behave like very dense clusters of matter, very specifically, such as the electron orbiting the nucleus of the atom like the Earth does the Sun. Or does it? What if in reality subatomic particles don't really behave like we expect them to, and our expectation of them is turned on its head and then shattered into a million pieces? Well, the behavior of these particles have been tested over the past about 100 years, and one of the most effective ways this was done was through something called the double slit experiment. Here, let me show you how it works. So this is how the experiment is set up. There's an electron gun around this area, firing electrons one at a time in a single direction, and the electrons are going to map themselves onto a wall they hit, which is in this case one of these posts, and the mapping location is going to give us a pattern over time, allowing us to deduce the behavior of the electrons. And between the electron gun and the wall, there's another wall, and this wall has two slits in it. And now, as you can see, there's only one slit, and I'm going to use that as a control to see what to base the results of the two-slit experiment off of. Now, because I'm not an actual electron on this scale, I am going to use knives to represent them. So logically thinking, when I throw these knives, they're going to land in a straight line across from me on the wall. Let's see what happens. Let's look at the results. Alright, so it looks like all the knives went through the slit in a straight line and hit the wall in the same post. Now let's see what happens with two slits. So because with one slit the knife landed in a straight line from where I originally was, the same thing should happen here with two slits. Let's find out. Let's add in one more for good measure. Let's take a look at the results of this one. Whoa! Well, first off, I am better at this than I thought I would ever be. Secondly, these knives are not where they should be landing logically. Take a look at this knife. If it had traveled in a straight line, it would have been obstructed by the wall with the slits and fallen short. And yet, it's still there. So the question is, how did this happen and how is this possible? Well, let me show you.
A particle won't give us these kinds of results, so there has to be some form of interference with it. Well, it can't be two different particles interfering with each other because they're being fired one at a time. And a particle can't have a sudden change of direction because the laws of physics say there has to be another force acting on it when we didn't observe one. So it's somehow interfering with itself. But can a particle do this? No. But a wave can. When after going through two slits, resulting two waves will interfere with each other, resulting in a scattered pattern on the map over time. And therefore, the electron isn't behaving like a particle at all, but rather like a wave.
Here's the more bewildering part about this all. Even though we know that there's a wave-particle duality within subatomic particles, scientists to this day still can't reason why, even through mathematical calculations. And this drove famous scientists like Einstein and Bohr to try and prove or disprove the existence of this. But, however, through experiments like this, we know that Bohr was right, and the wave-particle duality does exist, but we still can't reason why. But even though we don't know, we're going to keep persisting until we know, or at least attempt. And that, my friends, is the beauty of science. So sure, we've gone over the radical, revolutionary, and even somewhat chaotic theory that proves that there's a wave-particle duality present within subatomic particles. It doesn't really have much application in our day-to-day lives, simply because of the sheer scale difference. At an atomic level, you can completely and purely detect that there is a wave behavior within subatomic particles. But in the real world, there's so many atoms and so many subatomic particles that I can't even verbally describe them, that it's essentially undetectable at this point, which is exactly what's stopping me from chopping this bok choy with my trusty cutting device into multiple pieces at once. So unfortunately, this means I'm not going to be dicing my salads faster anytime soon. I guess I'll just have to stick with my skills for the time being. Thanks for watching.